Doctors Doug Clements, Christine Harradine, Chi-Ing Lim, Julie Sarama, and Megan Vinh at the STEMIE Center at the FPG Child Development Institute, UNC Chapel Hill, now present Learning Trajectories for Science, Technology, and Engineering.
Hi, Doug Clements with Learning Trajectories for Science, Technology, and Engineering. The following people contributed to the presentation, and it'll be narrated by myself and Christine Harradine. You might be wondering why Learning Trajectories for Science, Technology, and Engineering, but not math. I hope you caught the other presentation by Julie Sarama and myself that details the more well-developed learning trajectories in mathematics. Science, technology, and engineering, they're newer. So let's take a look. First of all, STEMIE's vision for the future is a set of learning trajectories that are useful, relevant, and validated through field testing and by STEM experts. There would be, then, a set of open source, free e-learning resources that are socially validated, high quality, useful, and relevant to both practitioners from birth to kindergarten and professional development experts and all in higher education and in all contexts to build their confidence and competence in supporting STEM experiences for children, especially with disabilities. So we'll also identify supports, research-based supports for practitioners to implement the learning trajectories to ensure that children with disabilities can participate fully in STEM learning, and these will be used to scale up the learning trajectories. So why learning trajectories? Once again, you could see our earlier presentation, but let's go into that a little bit now. And I will say, several people wrote this presentation. I am not in the habit of quoting myself. That was somebody else, but I'll take it. Any good teacher starts with where a child is. Then the obvious question is, how do you identify where a child is and where a child is going? You have to have an idea of a path, the road or trajectory through which children develop STEM ideas. So what did we do for that? We wanted to develop full learning trajectories. What do you mean full? Well, learning trajectories have three parts. There's a goal, then where do you want the kids to go? A developmental progression of levels of thinking through which most kids pass on their way to realizing that goal. And then instructional strategies or teaching in all its glory. What can practitioners and caregivers do? So, what about inclusion in learning trajectories? We take 3 steps, right? First, we want to make sure the activities and the routines are set up, the room set up, the equipment we have, how an activity is done, the length of time for this. And for routines, everyday things, how can they be enhanced to develop particular STEM learning trajectories? The materials, step 2, modifications to toys, materials, add adaptive technology devices, and everything else has to be considered. So again, full access to full participation for children with disabilities. And then instructional practices, and that includes interactions, everyday things and specific activities, intentional activities, and they can be modified by adding information, reducing steps for them, and the like. So embedded inclusion into learning trajectories does all 3 of these. And notice that instructional tasks where the adult practices used to individualize STEM activities are within daily routines, and the environment feeds back into materials design. So you can explore our micro lesson. There's the URL for it that gives you an animated view of a little more detail about learning trajectories. Now we're going to talk about, so if they're kind of not very well developed for the young children we're talking about yet in the S, T, and E of STEM. How did we go about developing it? Christine Harradine will take you on a trip investigating just that question.
So you're probably wondering how we are developing the trajectories. The short answer is through a lot of reading, talking, and garnering expert review. We have gathered all of this in a spreadsheet workbook, affectionately known to the STEMIE staff as the Beast, to track everything in one place. We're using multiple sources of information. We started with the scoping review, which I'll mention again in a minute. We did follow-up literature reviews, and then we separated all of the information into 3 buckets. The first bucket is child-level processes, such as observing, questioning, describing, exploring, etc. Cross-cutting concepts that apply generally to all domains, such as structure and function and cause and effect, made up the second bucket. Finally, we had all of the domain-level content. We gathered information about age, range, emergence, and duration of all of the items that ended up in the 3 buckets. And we gathered sources relevant to each finding. It was really important to us to track what we were finding and from where it came. We started our work at STEMIE with a systematic, comprehensive review of the universe to see what was out there on STEM for young children. This is called a scoping review. We searched 102 sources, such as databases, journals, foundation reports, and others, each with a set of 20 different search terms. We limited the search to children aged birth to age 5. If you're interested in hearing more about the scoping review itself, check out the mini chat session called Scoping Out the Research on STEM for Young Children with Disabilities. The follow-up literature reviews focused on science, technology, engineering, and STEM. We extended this search to age 7 because as we were studying developmental progressions, we wanted to know where we're headed. So we expanded it to slightly older children so we know what would be coming next. We were looking for the processes and the skills that develop in each of these areas. While the purpose of the Early Learning Guideline Review was to determine to what extent states are addressing science, technology, and engineering in their ELGs, information from the review has also been used to inform the development of the developmental progressions. The ELG work group reviewed the most current versions of ELG documents that are available online for all 50 states, the District of Columbia, and the Head Start Early Learning Outcomes Framework. A total of 52 guidelines were included and accessed through internet searches for specific ELGs. The 52 guidelines consisted of a total of 30,388 indicators, so this was a really big task. You can check out our team's mini chat called Review of STEM in State Early Learning Guidelines if you're interested in the work and the findings. In considering ways to seek a wide range of perspectives and expertise, and to engender ownership of the learning trajectories approach by a broad and diverse group of STEM experts, STEMIE decided to use the Delphi approach to support the development of the developmental progressions. As findings from our scoping review suggested, scant research evidence around engineering and technology for this age range, that being birth to 5, along with very little in all areas for infants and toddlers, the STEMIE team needed to identify another intentional approach to understand the ways that children learn STEM and the experiences that promote STEM learning. A Delphi approach was deemed a research-based methodology that was an appropriate way for understanding practice-based evidence and expert opinion. An open-ended round 1 survey was deployed in November of 2019. We are so lucky to have an invaluable team of experts who continually push our thinking and guide our work. They're extremely generous with their feedback and their expertise, and we're humbled by their contributions. If you have interactions with any of these people, please thank them. So where are we on the development of the progressions? We've sent it out to domain area experts in the field for 2 rounds of review. We hold regular staff meetings to discuss findings, new research that pops up, and to review the feedback from the experts. We're currently in the process of remastering the developmental trajectories with plans to distribute to the next level of Delphi review and to field test in the incubator sites. To talk more a little bit about our incubators, the goal of the incubator work is to field test all parts of the learning trajectories and to co-create materials with practitioners to support sustainable implementation. The rapid cycle field testing will include a number of steps. First, modeling the implementation of the investigations or teaching strategies. Second, we'll be providing professional development and coaching to practitioners around implementing the investigations and teaching strategies. Third, observing children's learning and development while engaging in the investigations. Next, making changes to all parts of the learning trajectories based on the observations and practitioner feedback. And finally, this is an iterative process, so we'll be engaging in the cycle again to continue to refine the learning trajectories. Given the scant evidence on STEM for children with disabilities, especially for infants and toddlers, the work with incubators is critical in co-creating with practitioners and with families and generating practice-informed evidence. Thank you for joining us. Please ask questions and make comments in the online discussion. And enjoy the rest of your STEMIEFest adventure.